Hey, hello everyone. My name is Hiren and I'm the co-organizer of GDG Ahmedabad. Today in our next machine learning event, we are going to discuss about deploying models to production with the TensorFlow model server. As we all know, in machine learning, when we build a TensorFlow model and we have to serve it over HTTP and HTTPS, so our end users can use that. So today in this event, we are going to show uh, how you can put your model into production, package it, and make it ready for the deployment, and upload it in somewhere in cloud and make an API so it can be consumed by your end client. For that, today we have a speaker, Rishit. Uh, he is a 10th grade student, and at age of 15, he has published 7 research paper, and he is very active in machine learning field, specifically in the TensorFlow. So let's welcome our speaker for today. Hey Rishit, hello. Rishit, you are on mute.
Hi. Yeah.
Yeah.
Hi.
Hi. Hi Rishit. So we are starting the session, and it's
Yeah.
over to you now. You can start with your introduction and give the introduction to session, and then you can start sharing your screen. So over to you.
Okay. Hi, folks. Thanks for coming here. Before we start, just that I've switched on captions from my side, and you do not need to switch them on from your side. I'm Rishit Dagli. You probably just read that down here, and I'm currently a student of grade 10 and a TEDx and TEDx speaker. A part of the things listed down here, I've often represented my country and won a few international hackathons and competitions too. And guess what? I love research. I have written 7 research papers in all. Also, just in case if you didn't notice, the first letters match too. Okay, so let's get started with the session. Today we'll be talking about how you can deploy your models to a production ready scenario. If you're not an expert at TensorFlow, it does not matter. The talk would still make sense to you and you'd be able to follow all what we'll be doing. With that, let me just tell you who the ideal audience would be for this talk. It would majorly be people who have worked with some deep learning models and maybe made a few deep learning models. It could be with Keras or TensorFlow too. Uh, all it doesn't matter for this session. And developers who want to take a leap from the models they built into a production ready manner and start serving the model to their users. So before we move any further, let's just discuss what we'll be doing or the agenda for today. We'll be starting out with the motivation behind all of this and why should you care. We'll then see what you need to do for deploying your model and then how you can implement it for yourself. So let us get started. This is actually a very accurate representation of the ideal scenario. Your model works well or does a good job in the testing or development set, and when you bring it out into the real world or the production, that is when problems start coming and things start failing because you have a kind of different audience in the production set than the development set if you're not doing your steps properly. When you bring it out to the production environment, you'd also need to have a resilient pipeline to serve your model and an efficient way to pass data and give your users what they want. And this is just one example of what might happen in an environment like this. When I say resilient pipeline, what I mean is if your pipeline fails, it should be able to get back up very soon without affecting the performance for your users. So that's just one example of what you need to do for making your model production ready. We talked about how production environment is different. So let us now see what all you would have to do in order to deploy your model efficiently and make it available when your users or your application maybe needs it. What I'll also assume is you already have a trained machine learning model. So, first, you'd of course want to get the model and package it in a way that you can use it in a production environment. You ideally would not put a Jupyter notebook in the same format into production. Some of you might tell me I can if I wanted to, and it's a heated debate topic, but it's generally not advised to do so. And you ideally should not directly put a Jupyter notebook into production. Then you'd want to host your model on some cloud hosted server so you can serve your users, provide them the model whenever they need it. Now that you have hosted your model on a cloud hosted server, you also need to maintain it, right? One of the main things which I refer to while saying you need to maintain the server is auto scaling. You should be able to handle your users if you experience an increase in number of users drastically. So if you experience an increase in number of users, this would also require you to increase your number of resources. And so with the increase in number of resources, you would be able to serve your users well. That is the motive behind this. And hopefully you have many users and from all around the world. So you would also want to ensure global availability. So if your users are in maybe one part of the world, it should not happen something like they are not having an access to the model, or the model does not work well for them. This also means that if you have maybe a NLP model which does something based on text, you would want your model to maybe support regional languages. So a lot of times what happens is you train the model in English and maybe deploy it in somewhat Hindi or something like that. So your users use something like Hindi or some other language. Sometimes it becomes too troublesome and you just cannot get the right output from it. So there are quite a few methods to also do this. In fact, some research is going on how you can do something like train the model in one language. Maybe I train the model in language A and deploy it to language A, B, and C. But you'd also need to ensure that you're doing this correctly. And that's not it. There are a few other things to consider, like security and latency, too. But these were the major things which you need to take care of. After this, one of the most important ways is to provide a way for your model to interact with your devices. Most probably, you would need to provide something like an API to work with, which you or someone could call your model and get the predictions back. So you'd also need to ensure that the API is up and running all times. It allows the user to make predictions from your models, and you'd have an API to be working all the time. So tomorrow, when you maybe tomorrow or some other day, maybe when you make an update to the model. So let's say you do some image classification task, and you trained your model on some set of data which was from past 5 years. And after 2 years, your model gets outdated, right? Because you have new data coming over, new data on which you want to do classification. So your model maybe cannot work well with the current data. So you need to make an update to the model. Maybe even change the architecture. So when you make a new update, you also need to ensure that your users get the latest version of the model. As if you give some of the users an older version, some of the users a new version. It would create a bad experience for your users. So you would also need to ensure that your users get the latest version of the model. And we'll talk about this in a great detail in some time. Now that you know what it takes to actually deploy your models to a cloud hosted server, let's see what TensorFlow model server is, and more importantly, how it can help us. So why care about TensorFlow model server at all? TensorFlow serving is a part of TFX, or also called TensorFlow Extended. Simply enough, TensorFlow serving is an API that is designed to help you make production ready machine learning systems. As said in this session, we'll be seeing only a specific subpart of TensorFlow X called TensorFlow serving. So TensorFlow extended, you can understand it as simply as TensorFlow serving is a part of TFX. So this is all what you would have to do to create a solution with ML, and this is where uh, and and this is where I and this is where your serving infrastructure comes into place. If you see your modeling is indeed a very small part of deploying your model. So I'm not saying modeling is not an important part of making a model, bringing it out into the world. What I'm saying is modeling is not the only important part while while taking a model and bringing it out, serving it to your users. So modeling is definitely a part of it, but it also makes sense investing your time into a few other of these processes, namely serving and your serving infrastructure, how you'd want to serve your model to your users. So now that you know what TensorFlow serving does and what TensorFlow serving is, let us see how it can help me or what it can do for me. So let's start out with a quite common use case. Yes, the brain thingy here is a representation of a model. So the brain thing here is the representation of a model, and you made the model, and you maybe deploy it with TensorFlow Lite maybe. So your users could directly have inferences running on their mobile or on low power edge devices, or maybe embedded systems, or you could or you may have created a JavaScript representation of it and have your model work in the browser itself, maybe with TensorFlow JS. Many times it's better to have a centralized model. Maybe the centralized model is somewhere hosted in the cloud where your devices can send a response. The server would execute these responses and send them back to the device that made the call. Remember, we talked about model versioning in an architecture like this. You would just need to update your new version of model at the server, and all your devices, people running your model on the web, people running your model on embedded systems, or people running your model on mobile devices would instantly have access to the latest version of the model. However, if you use the traditional approach like sending out maybe app updates, um, some users have the new model and some users would still have the older model. This would create a bad experience for your users, and you definitely don't want that. In a cloud based environment, to do so, you could use dynamic assignment of resources according to the number of users you have. So, uh, So maybe if you have a lot of users, you could have more amount of resources to serve those users, such that when maybe more amount of users send a request to your app, the cloud hosted server can process all those requests and send them back to the device that made the call. TensorFlow serving allows you to do this quite easily too. So you don't run into issues like, oh, I just updated my model and my server is down. Or maybe you might have heard this quite often, I'm updating this, I'm updating that. All users will not be able to have access to it. I need to switch down my server and things like that. So you're not face all of these problems with TensorFlow serving. So TensorFlow serving would essentially make this process a lot easier for you. So while you focus on the real code, or you focus on the logic which actually runs your app or your ML model, TensorFlow serving does the infrastructure part for you. So a major motive of TensorFlow serving is that you don't care about the infrastructure. What you care about is making your app, writing the real code for the infrastructure, and TensorFlow serving abstracts the infrastructure part for you, getting all of these things we talked about, maintaining the server, upscaling it, downscaling it, things like that. TensorFlow serving abstracts them for you. So you can focus on the real code, making your real app. So let's get started with some code and see how this would be done in practice. So of course you need to install TensorFlow serving, and we'll not waste time over installation. It is very straightforward. You could refer to some commands at this URL. Is the official docs URL to install TensorFlow serving, and the process is pretty straightforward as I mentioned. So what I'll do is I'll give you a moment to make a note of this, take a screenshot, or however you wish. So I guess you might have made a note of this now, and let's get into the process, and we'll see how all that we talked about comes together in practice with TensorFlow serving. So you already have a model, and the first thing you would do is convert the model into into a format which is usable by TensorFlow model server. So what you do is simply save it as a saved model format. So uh, the third line here, which tells directory path, shows where where to save your model, and the other two lines just pass the inputs and the outputs to the model. So you would simply save it as in the standard saved model format uh, for TensorFlow. If you navigate to the path where you save the model, you would see a directory structure like this. Also, I made a directory named one manually, uh, so which is my model version. We'll see how TensorFlow model server helps us manage and deploy these versions. And also note your model is saved as a .pb in a .pb extension. So there is also a cool utility called saved model CLI, which allows you to get greater insight with this on what you have in your saved model format. And what we'll be doing here is we'll see the saved model CLI in action in the demo itself. So I'll not show you how the saved model CLI works at this moment. We'll see it in the demo itself and how it is helpful. But just a sneak peek, it's a cool tool, a cool utility. So you just converted your model into a saved model format, the standard saved model format. And now that you have a saved model, the next logical step would be to go and start serving your model, right? And let's do that. So here what I'm doing is I'm just specifying the model directory, nothing new as such. So here's how we would start the model server. Let us understand this line by line and break this down. So, so the third line here in this slide tells it to use TensorFlow model server. Of course, you would not include the bash magic cell, which is about the double percentage bash, the bash magic cell while implementing it. But as I assume, most of you might use or will use Colab. Um, so most of you might use Colab to follow along in this tutorial. So I have added that as a Colab specific thing. So you can go ahead and run the same snippet in Colab itself. So I've added the bash magic still for you too, as Colab doesn't provide you a direct terminal access. So we have the TensorFlow. So the third line tells you to start the TensorFlow model server. This part is pretty straightforward. You are specifying the port on which you want to run your TensorFlow model server. So your model should be served on localhost the port number. A thing to note here is the URL which you'll be using to serve your model. So the URL will include your model name. When you maybe use the model in an app, you would so remember we talked about an API which would be able to serve your model such that whenever I call the API, I should be able to get predictions back from it. So make a note of model name. The model name would appear right in your API. So you would have model name as a part of the URL, which you'll use to call the API, which will predict things over your model. So I've just included a simple model name, and now I'll specify my model path. Remember, I made a variable for it above, and then I also want to have some logs. So I'll see so I'll also log them. So maybe I can know some errors. If I run into some errors, I can quickly debug them. So I'm also turning on the logging. So you could maybe use some of that in your projects to quickly debug things. We talked all about setting up your model server and making an API for it, hosting it on localhost, some port number. So that was all about setting up your model server. Let us now talk about the part I'm most excited about, doing inference. And that's also the major thing we want to do, or aim, what we want to achieve. At the end, we want to do inference from the model. While passing the data in, there's an important thing to note. Uh, a lot of people run into errors with this. You should know that TensorFlow model server takes values in lists of lists. This in fact makes our work a lot easier. Let us see what this means and how you should pass your data into model server and how you should not pass your data into model server. So as you can see, my data is in the form of list, and each of my cases will have all the feature values. So This means that I have a list. So I have, um, so how do I say? Okay, yeah. So I have one. So I have all of x1. So okay, yeah. Sorry. So I have case one, which is which is my first input case. So inside the case one, I should have all my features, which is x1, x2, all the way up till xn inside this case one part. In the case two part, I have x1, x2, all the way up till xn for my second case. So maybe I have two images on which I want to do predictions. All the image data for image number one would be inside this list, and all the image data for image number two would be inside this list. So, which makes it a list of lists. So, as you can see, I have a nested list over here, and this also makes it a lot easier for me to do inference, because now what I can do is I can simply call up, um, I can simply do something like pass in four or five images at one time instead of having to go through a loop. So a salient advantage of TensorFlow model server. If you know a bit about saved models, you might know about signature definition, or as called in TensorFlow, signature def. For folks who don't know about it, uh, what the signature def does is it defines the signature of a computation supported in a TensorFlow graph. So you can have support for IO for a function, and you can easily find that by inspecting your saved model. And in the instances, uh, and in the instances part, we'll just I'll just put in my x's. I'll convert my x's to a list, and I'll just put in my x's. So you'd also be expected to fill the signature you are using for your saved model. We'll see how you can get the signature for a saved model, and what you would have in the place of the empty quotes over here, which say which signature definition are you using. For most of the models, it's usually serving underscore default, but we'll see what values this can take and how you can find about this. Now I have my request set up, and I can simply make an inference request now. Remember us talking about versioning and how versioning is so important. And this is how TensorFlow model server handles them for you. I had the version set to one earlier. Remember the uh, remember the directory structure I showed you? I had a directory named one, inside which my saved model directory was present. So you can see the URL I use for prediction, and this in fact makes it very easy for you to manage your URLs, to manage your models. You have a v1 in the URL, which tells you that okay, I'm using version 1. So this is in fact, you can just see how easy it is to manage all of this, and you again didn't have to do any of the heavy lifting work making it work on v1 and things like that. Also, another thing about TensorFlow model server is maybe when you put out a version 2 or v2 in your model, what you do is simply change this URL to v2, right? So with that you can also have a default fallback to version 1. So your version 1 would still be active, still be hosted by TensorFlow model server. So you can anytime have a default fallback to version 1. If things don't work out in version 2, just change the URL back to v1 and things get normal. So that's how easy TensorFlow serving makes it for us. The test here is the model name I defined earlier. So remember, I defined my model name earlier as test. So that is what appears in the model URL. So first so let's see what this URL does for me piece by piece. So first I of course have my local host, port number on which my TensorFlow model server is running, the version which we just discussed, how TensorFlow makes versions easier for me. And then I have the model name over here, which is called test. So if I have multiple models in my app, all I can do is simply have a URL and just switch to my model names. Maybe I call one, model 2. So all I'll do is v1 models model 1, v1 models model 2, and simply that's how you can call multiple models too. So the URL management too becomes a lot easier with TensorFlow model server. Uh, you can also see, oh, sorry. So you can also see I have this predict written at the end. So again, this is just a way for me to know that I'll be I'll be getting some predictions back from this URL when I pass some data to it. So just some semantic meanings. What I'll also do is I'll pass my data and my headers. And once I pass my data and my headers, I'll get a JSON response back. So now you are all set to start serving your models with TensorFlow model server very easily. Some of you might feel an interesting case would be to see how images would do. So, what's an image? Uh, so, how do you represent an image? A list of lists, and it's as simple as having a list of lists. Okay, so simply put an image in. Let's simplify this down. So simply put an image in the case one which I mentioned. All what you have to represent your image in case one. I have all the code written down for you in the GitHub repo for this code. I'll for this session, and I'll be linking you to the GitHub repo at the end. Make sure to try out the code for yourself and get a hands-on experience with it. Try working your way around code. We'll also be seeing the code now. So now that you know how TensorFlow model server works and how you could use it, having known the others, here are a few more things TensorFlow model server could provide for your use case. Now you can understand that if, let us say, you deploy a version 2 of your model, in case of any problems, your version 1 will still be active and usable. We just discussed this. If you have any problems with version 2 of your model, maybe you can have a default fallback to version 1 of the model. And it's made easy with TensorFlow model server, a lot easy with TensorFlow model server. What you can also do is you can have something like your app maybe chooses the latest version which is available. So that's also something cool. You can serve your users the latest version of your model, which is I feel again something cool to be done very easily with TensorFlow model server. Also, while the time your new model version is being deployed, so you go into the process like maybe post it on a cloud hosted server, wait for the API to get active to be able to accept responses, be able to do the auto scaling part. Your older version will continue to work just as normal. And these things are often quite helpful. So you have no server downtime. while updating the model or making a new version of the model. And TensorFlow model server helps you in doing so. So you have no downtime now while you're updating your model or maybe making patches to your model. And that is also something really necessary to for a production ready application, or maybe any AI application. You need to have almost no server downtime. We discussed a bit about this earlier, and a major aim of TensorFlow model server, as you might have understood it now, is to let you focus on writing real code and not worry about the infrastructure. So, how do I deploy my application? How do I deploy my AI application? Or how do I allow my users to use it seamlessly? How do I have something like no server downtime, which we just discussed about? Uh, is is something which TensorFlow model server abstracts out for you. And of course, you don't want to spend time doing all of these infrastructure thingies. So as a result of this, you spend more of your time into building the real app rather than managing the infrastructure and build, and as a result of which you build better apps. I feel even if you see TensorFlow as a whole, it and not just TensorFlow extended or TensorFlow model server, you see TensorFlow as a whole, it allows you to focus on the real application, on implementing your idea rather than figuring out what problem I made in back propagation or why my gradients aren't matching and things like that. So it's always been about writing the a real application, implementing your idea, rather than focusing on low level things and intricate details. So TensorFlow model server does quite a good job in that too. And you just saw how easy it was to get a model to your users. The things which we saw now could be well scaled to the cloud, making it even more powerful. So you could always maybe have your own server or maybe a server farm, and we'll not be discussing cloud or why on premise here. And um, but what I can tell you is with the cloud you can have a greater upscaling downscaling according to your number of users. So you use more number of resources if you have a higher number of users, and you automatically reduce your number of resources if you have a lower number of resources, if you have a low number of users, sorry. So that is something which you would want to do. And how so we'll also not be discussing about how load balancing takes place. However, we'll see a brief workflow through this, how you would want to host your model in the cloud, and how you could also make inferences out of it and do auto scaling all on your own. So the first thing that comes up to your mind when I maybe say cloud or hosting your model on the cloud is I can have one VM in the cloud doing everything. So if you can have one VM in the cloud doing everything, why are we discussing about it, right? I can simply make a single VM, push my model, start the TensorFlow model server. Why are we discussing about the cloud-based approach? So I want to have a system, as I said, upscale or downscale according to my need. I should be able to manage all my new users, if I have any, by increasing my compute and disk. We also talked about this a bit earlier. Since cluster creation and so what we'll do is we'll walk through the process for making a Kubernetes cluster to do so. So we'll follow a containerized approach to this, such that you can have the downscaling and upscaling for you very easily. So since cluster creation and deployment can take quite some amount of time, maybe if you have worked with Kubernetes and GKE, you maybe know that cluster creation sometimes just takes a lot of time. So what I'll do is I'll instead walk you through the process. I believe all of you would have an elementary idea about what Docker and Kubernetes is. I'll start by assuming that you have trained a model and you have also built a Docker image for it. So, how do you do that? So, you simply take the train model, convert it into a saved model directory format, or the standard saved model format, which we discussed about. I also gave you a command to do so. We'll see that again in the demo section. But you have your model as a saved model and make a Docker image out of it. So that's just the standard approach of what you would have for building a Docker image for your model. The steps to doing this are, so if you want like step by step approach to this, the steps to doing this are in fact pretty straightforward. And I've also listed them in the GitHub repo for this session. So what we'll do is, as I walk you through the process, I'll also show you the code which I'll be using. So what we'll do is I'll start by um, creating a Kubernetes cluster with 5 nodes, and I'll be showing how you can. Um, so I'll walk you through the process for deploying a simple ResNet model on the cloud. So the name ResNet Serving Cluster. I've also showed an example, a step-by-step guide for the same in the GitHub for this, in the GitHub for this session. So uh, in that, I use ResNet as a model to show. You can, of course, very easily have your own models. So in case of this, what we'll be doing is we'll just be downloading the ResNet model and making a saved model directly out of it, or saving it in a saved model format and pushing it as a Docker image. For your use case, what you could do is simply convert, instead of downloading the saved model directory for somewhere in the internet, you make your own saved model directory with your model and just do a Docker push with it. So, as I said, then of course you need to push your Docker image to the cluster you just created. So, uh, uh, so I've used the pre-trained model ResNet as I just said earlier, and I can simply push it to Google Container Registry as an image. So so this would be the foundational part for what you have as a model. So I take the saved model directory from a Docker image, and with that you're all ready to create a deployment. I have a simple YAML file or the configuration file here, which should create the metadata for deployment, like your image and the number of replicas you want. I've included a sample for how your metadata file or your deployment file would look like in the repo. So I'll advise you to check that out once. I'll share the GitHub repo link with you soon. So with that, I can simply create a deployment on Kubernetes. So the major part I want you to take away from this is, um, you can very easily have you can very easily serve your model on the cloud with TensorFlow model server and Kubernetes to scale up and scale down and do container orchestration as a high level overview. So all you need to do is, essentially the main steps you need to do are train your model, get it into a saved model directory, and push it as a Docker image. And you can go on then to deploy a model on the cloud. So there would just be one difference when doing the inference, which is instead of using external IP, instead of using the local host, so we said local host colon the port number. So instead of using the local host now, what you would do is you would use the cluster external IP. So just there's one small difference while doing the inference. The inference model URL, instead of being localhost colon model number, we'll have the external IP of the cluster colon model number. So with that, you just saw how easily you could scale your deployments. Oh. This repo has all the code that we covered today, the cards we discussed about. You could even run them in a collab environment. So go ahead and try these codes out for yourself. Also, if you make a project or use TensorFlow serving to help you in a project, do the infrastructure part for you in a project, be sure to share it with me. And let's go to the demos part, the part I'm most excited about. So what I'll do is I'll quickly switch my screen so you could have a look at my screen. Okay, I'm switching my screen. Hold on a moment. Yeah, it's here. Okay. Okay. Good. We so this is the GitHub repo I talked to you about. I have all these steps listed over here. What we'll be doing is we'll see how a simple image model could be used with TensorFlow serving. So let's go ahead and run it out for ourselves. So okay, I'll I'll just do some imports up over there. So what we'll be doing is we'll be making this model. We'll be trying to serve a model based on the fashion MNIST dataset. So I guess a lot of you might have worked with the fashion MNIST dataset. It's quite quite famous dataset too. So I'll just load the fashion MNIST dataset, some simple parts. So let's go ahead and make a model. I'll just make a simple model as you can. Okay. So while it trains, it will not take much. It's just a simple convolution layer, a single convolution layer. So and a dense layer, just that. And I'm running it just for 5 epochs, as you can see over here. So I'm running it just for 5 epochs. Very simple model. It just takes almost 15 seconds to run. That's it. So fast. Uh, yeah, I'm just running it for 5 epochs. And I have a test accuracy of almost 87%, which is not that good. But for the purpose of this demo, I ran it in just 15 seconds, right? So in just 15 seconds, I could get a good enough accuracy to start with, 87% accuracy. So let's go ahead and save my model in a saved model format. So I'm using the similar syntax I showed to you earlier, tf.kdis.models.save model. So let's go ahead and save a model in a saved model format. So once this model is saved, let's also go ahead and see my directory structure. Yeah, so it should be in temp. What I'll do is I'll quickly go on to oh, temp, so you can see the directory structure which I have. Yeah, so I have the model directory named one. So here I can see my model is in the format of a saved model .pb file. We just discussed what the pb file does for me. So I can see my model is under the folder named one, which is the model version, and there's a saved model directory right over here. So I told you about a cool tool called Saved Model CLI. So Saved Model CLI, it's just a bash tool which allows you to gather great insights about your saved model. So let's go ahead and run this. Let me show you what I could do with this. So I personally use Saved Model CLI a lot. It allows me to prevent a lot of errors while using open sourced models, while trying to use transfer learning using open source models from the internet, specifically in that case, and also while making my own models too and serving them. So I can see I have my inputs and outputs listed over here. So I can simply get my input shapes, output shapes right from here. What you can also see if I scroll down, uh, okay, yeah, sorry. So what you can also see if I scroll over here is you can see that my layers too. So I have my convolution layer, and down over here I have my dense layer. So it's a pretty it's a pretty useful tool to work with. So and it just happens to be quite useful to when you are working with a model and trying to know what's inside the saved model directory. So I'm so this is just something which is related to collab. I'm quickly installing TensorFlow model server. So I'm trying to kind of do this live over here. So in a collab, I have to install the TensorFlow model server again as I'm doing it live over here. So I'll just get that. Till then, let's just specify my model directory. So that's where my model is present. And here's the part where I'll start the TensorFlow model server on port number 8501, or maybe any port you want. I'll give a model name to and have some server logs. So let's go ahead and run this in a separate thread. So let's just see a few server logs, and I can see that my model has now started, and it is now exporting. Uh, it is now exporting an API at localhost colon the port number which I just mentioned. So let's go ahead and try to make a request to the model. So this is just showing me a random image from the test images. So maybe run this again. Yeah, it's just showing me a random image from the test examples. So I can know. So what I'm doing is I'm just taking image from the test examples to know how my image looks like. So I'll specify my signature name, which I found out from seeing the saved model CLI outputs. My instances. Now, this is where I mentioned the salient advantage of TensorFlow model server. I can simply specify uh, first three images of my test images and convert them to list. So it's already in list format. So I have to do no more things for it. So that's that was what I wanted to contain in my um, that is what I wanted to contain while making a REST API call. So let's go ahead now and make the API call itself. See what we get. So as you can see over here, I mentioned it to do inference on three images. So I should get three images I've also included something that allows us to know if the prediction was right or wrong. So I'll just get the prediction, make a REST API call, and it will be a dictionary. So from the dictionary, I want to get my predictions out. So what we'll do is we'll quickly run this, and I'll show you how things look. So let's go ahead and make a new code cell over here, and we'll print out predictions to see what I get back. So I get back. Oh, yeah. So I get back a huge quantity of numbers, which is what my model. So which this represents my images. So what I'll do is I'll I'll make a new variable which contains just this, so you can know what is the raw format of things coming out from my TensorFlow model server. So I'll just write this something as a equals, yeah, yeah. So I have it over here, and what we'll do is we'll make a new code cell, print out a this time. So I can again see uh, these images. But if you see new variable, forget the name for now, but this is what actually my TensorFlow model server is giving a response back. It's giving me a dictionary, and there's an ID called predictions, which has all of my images. So what I care about is the predictions ID. So I'm just specifying I want things from the predictions, and let's go ahead and run this. So I'm just taking the first one from it. So the model thought this was an ankle boot, and yeah, our model did a pretty good job of making a right prediction over here. So let's just go ahead and try one for that matter of fact. And yeah, we'll try predictions of one. So let's try the second image. Yeah. So um, it again classified the things right, and my model again did a good job in doing so. Also, if you notice what these are essentially, I'll just take on any one entry taken at random. So I'll give you like a moment to think about what do these numbers signify. So a tip: fashion MNIST has 10 classes, so 10 classes to choose from, and there are 10 numbers here. Okay, so if you guess that these are probabilities, you're right. So what each of these are is probabilities that the images of one class. So what I just do is take out the probability of the one with largest. So I'll just take out the one which has the largest probability in the predictions list, and I'll show that this is the class which has the largest predictions. So also, I just noticed this. Sorry, uh, it showed me this is a pullover, and it is showing me an image of an ankle boot. So that was pretty absurd. I forgot to replace this zero with one. Let's run this again. So it should give me an image of a pullover. Yeah, so this is a pullover right image displayed now. I just forgot to replace the zero over here with one. So yeah, and also I want you to notice the V1 over here saying I am using version 1 of my model. So that was about the demo of how you could how you could deploy it in the how you could use TensorFlow model server to make deployments. What I'll quickly switch things again. Yeah. So let's do a quick kind of recap of what we covered today before moving to question and answers. We started out with why it is worth to have a process for deployment. We then saw what is required to deploy a model, versioning, global availability, uh, a global nature for a model, infrastructure, and a lot more. We then saw what TensorFlow Model Server provides us with and why you should choose TensorFlow Model Server to make deployments. Then we saw the process involved with TensorFlow Model Server. You then saw its capabilities, how it allows you to write real code and not worry about infrastructure, the version wise URLs, and easy management. We then moved to see how this could be replicated on this cloud and saw a simple example of how Kubernetes could make this easy for us. I also have an example where uh, in the GitHub repo, where I show how you could use Kubeflow to do this, which is in fact based on Kubernetes itself. But it's good to know how you could do this since we are running out of time right now here. I'm not showing you the Kubeflow demo right over here, but there's a step-by-step guide in the repo. So go ahead and kind of read it out. And I hope you noted down the repo link. And here are a few of my social links. I'm most active on LinkedIn and Twitter. I've written quite a few blogs on Medium too. And I also love contributing to open source content. You can find me on these social medias. Also, if you make any project, I think I said this earlier, but yeah, I said this earlier, but if you make any projects which use TensorFlow serving, or TensorFlow serving helps you in any projects, feel free to share it with me. I'll be all open, all ears to hear about your projects. So with that, let's move on to the questions. See, I'd like with that now. I'd like to take any questions that have come.
Right, Rishit. So, first of all, it was a really good session, and I'm sure all of our audience understand about what is the TensorFlow model server and how it can be utilized for deploying the model without worrying about the server infrastructure, because that's where most of the developer
Yeah.
faces the challenge, that how to maintain the server infrastructure or how to create a server infrastructure that could be scalable. So yeah, that's where the TensorFlow model server is really helpful, and I'm sure all of our attendees of this session today had a good understanding of that, and now they are going to try it on their side for implementing the TensorFlow model server. Now let's take out a few questions. Uh, this is one question from Pujan. I think you already gave an example of how you can specifically work with the images in your demos, right?
Yeah. So,
Right.
so I showed an demo of how you could work with images. We worked with the fashion image dataset, but but a simple overview of a high level overview, I'd say, of working with images would be. So you remember that slide where I had case one, case two till case n, and how I would pass my data into the to TensorFlow model server for doing inference. So in place of case one, I'll have all the thing which is which represents my image to break. That's just a simple way of saying this. So maybe it is a list of lists. That what makes an image a matrix of numbers. So I have all that thing in my case one or case two. So I have all the things related to one image in case one, which I pass for the inference. And that is just how you would work with images.
Right.
So TensorFlow serving makes that easy too.
Yes, great. There's one more question. Serving of images, is it like reshaping the pixel values to 1D shape as input?
No, so what you can do is you can of course reshape your inputs to a 1D shape, but you could also pass in two-dimensional things too. But what I'd always advise you to kind of flatten out your pixels into 1D if you could. But this you can always pass in 2D numbers or pixel values too. That can also be done. It's not something like you have to stick to a 1D shape.
Okay. There is one more question regarding TensorFlow. Yeah, is it written in C++ or any other low-level language? Backend code
So
implementation of, yeah,
so
yeah,
I'm actually not very sure about how the backend code is written itself. Um, but as I can say, a lot of TensorFlow is written in C++. I would say most of the TensorFlow is written in C++, and again TFX is just like a wrapper on it. So as for any other level language, no, TFX is not written in any other low level language. But I have not actually worked with how things are inside the C++ version of TFX, the one in which it is essentially coded. So I cannot tell you about how it would be to work with the C++ implementation of TFX. But it's
right.
not written in any other low level
Yeah,
language. Sorry to interrupt.
right. Yeah, right. So it's like while working with TensorFlow, you don't have to worry about the low level
Yeah,
languages, because TensorFlow APIs are wrapping up all those low level languages, and it gives you clear interface in terms of implementing your code in Python. So yeah, but at the back end, TensorFlow is using C++ in
yeah.
various places, right?
What
There
I
is one
also
more.
feel is sorry. So what I also feel is cool is with TensorFlow, it's not limited to you having to use the Python wrapper. So TensorFlow doesn't tell you you have to use the Python wrapper. I can't do anything for you. If you maybe want to use a C++ version of TensorFlow, you can still use it, which I think is really cool for industry applications.
Right. So there is one more question. Can I upload my model to Amazon S3 bucket?
Yeah, well, you can upload your model to an Amazon S3 bucket, but there would be some differences for it. So I just showed you how you could do all of this auto scaling part in GKE or Google Kubernetes engine. So Amazon also allows you a way to Amazon or AWS also allows you a way to use Kubernetes, and the essential idea behind this would remain same, but of course your commands would change. And
Yeah.
as uploading to an Amazon S3 bucket, what I feel is instead of like what bucket is just a way for you to store data, right? So you can't store the data on a Amazon S3 bucket or a GCP bucket or somewhere maybe on your private server too. So what we talked about was making deployments.
Right.
So
Right.
that
So
can be done.
S3 is just a storage space,
Yeah,
and when you are using any of the AWS services, like in AWS as well, you have GPU based instance which can be utilized for
yeah,
training the model. So at that time, if you want to store your data, then S3 bucket is the best option, because that directly works with the Amazon directly works with Amazon instances, so you don't have to worry about storing the data. So yeah, it can be used for uploading model to S3 bucket.
yeah,
Right. So there is one more question. Please talk about GCP implementation of deep learning model too. I think that we can. It's kind of another session request,
yeah,
we can say, right?
yeah. What I'll but at the current scenario, since this question has been asked, what I'll do is I'll provide you a high level overview. So uh, a GCP implementation of deep learning model is, as I understand the question, is how do you deploy the model on GCP, right? So Is that maybe what you were asking? So did I understand the question right? Um,
1 minute. I think yes, this was the question. So
I
right. So
think
I
that
think
is what Rajendra
yeah.
meant.
Yes, yes. But anyways, we can talk about this in further detail, because as I feel is that GCP implementation of deep learning model, it could be another session. It can be a practical hands-on
Yeah,
session where we can show how you can deploy and train your deep learning model into GCP, right?
yeah, that would be better. Uh,
Right.
but just as a high level overview, as I said, what you can do is if you want to directly implement your model on GCP, make your model on GCP itself. You could look into a few services like AI platform and AutoML. That's just a high level overview. Nothing in detail, nothing specific.
Right. Now, to answer this question, Anubhav, uh, AWS EC2 or AWS EMR. So, Amazon has a lot of different type of instances, and while deploying or training models to Amazon, it requires you to have the GPU-based instances, because that only gives you the enough computing power, and that's where you will get enough speed or for training the model. So do check out on Amazon EC2 pages, where you can find out GPU-based instances which can be utilized for training the machine learning models. So hope we have answered that question. Right. So I think we don't have any more questions. So we can wrap this session up. Well, thanks a lot, Rishit, for joining us today. And please, everybody who is watching this session and who is going to watch it on the YouTube, if you have any other questions for Rishit, you can contact him over the Twitter or LinkedIn, as he has mentioned the contact details on the slides. And Rishit, do share your presentation, so I can share it with all the members of the community, so they can reach
Yeah,
out to you for any other questions. And do share out the link for the repository, so that is also can be shared, so that they can try everything on that side, right?
yeah,
All right.
yeah.
All right. So thank you everyone for joining us on this session today. And do watch out, do give us your feedback for this session, and do give us your suggestion on what kind of events and what kind of topics you want us to cover in the upcoming events. And do watch out for our next month event announcement. We are soon going to make an announcement for our next month events. So stay tuned. Till then, thank you everyone for joining, and hope everybody is staying safe at home, right? Thank you everyone. Thanks a lot, Rishit.
Thanks.
Bye.